Welcome to the video on computing productivity. The purpose of this video specifically is to go over how to compute single factor productivity. Please go through the video as you would normally, and remember that there will be just a few questions in the video just to make sure you're able to follow along okay. And then, as always, bring your questions to class, because that always helps kind of get the class going if you've got questions specifically on how to do things. So here we go. So first things is that this is a problem where Larry produces boxes. Specifically, he produces 240 wood boxes per day, and in order to do this he needs 100 logs. So in this problem here we're computing log productivity. So essentially what we want to know is how many boxes can be made out of one log. So we do all productivity problems the same. We take output and we divide it by input. So as you can see here in this, I've written out, I've got output divided by input. Our output is 240 boxes, so we'll just note that here, divided by 100 logs. So this gives us a productivity output of 2.4 boxes that can be produced for each one log. So we take the log, we cut it up into pieces, and we are able to then make 2.4 boxes from each log. Now, this annotation here is pretty important because this is always what productivity computations tell us. They tell us some number of units, and in this case it's boxes, so whatever it is you're making, it's always that many units can be made from this much resource. So if you always remember that it's this slash is like per, kind of like the word per, and then the resource follows, so we'll just note this as resource, then you can always kind of remember what it is that goes along with the number that we compute here. So I think I said this in class, this number here is never difficult to compute, output divided by input. We can all do that on our calculators, but I think what becomes confusing is what is the meaning of the number. Can we make 2.4 boxes per log? Does it take 2.4 logs to make one box? You can just see how the confusion sets in. So just some sort of note in your notes to tell you what this number means, I think, is a really good idea. So let's pause here for a moment and do a quick little quiz question that gets at this idea. So down here I even go so far as to say, you should take some time to interpret this. And so I just wrote out that this tells us how many units, okay, and it's always going to be the units, the numerator, can be made per each one unit of resources. So in this case it's logs. So now let's move on down here to this next problem. Same idea, right? We're still at Larry's logs. He's still making 240 wood boxes, but this time it's telling us the labor productivity that's required. So in this case we've got 240 wood boxes made with 100 logs, but we're not really interested in the logs as much as we're interested in the labor. So in this case we have to convert the logs into labor hours, and the way we do that is by multiplying the number of logs times the amount of labor per log. So in this case I tell you that each log requires 3 hours of labor. So essentially we have 300 labor hours. So we take 240, we divide that by 3 times 100, and we're going to get 0.0800. And then let's go back over here to interpretation and write out what this means, because this is really important. This means that for each one unit, which in this case is a box, So in interpretation, it tells us the boxes per labor hour. So in this problem, 0.8, right, so not quite a whole box can be made per 1 labor hour, which makes sense since we have more labor hours than we do have boxes being produced. So again, easy enough to compute this 0.800, but sometimes it can be challenging to interpret that. Now let's take a look down here where we have computing single factor productivity once again, but now we have a little bit different problem. It's changing slightly so that then we can compare this one to the previous. But in this one we have the same idea, right? We have 260 units that are produced, a little bit more, with 100 logs. So this is a new supplier. He wants us to buy his logs, and he's telling us, oh well, you know, my logs are better than your logs because you can produce more boxes out of my logs. So indeed you can make 2.6 boxes per log, so that's a good thing. But now what we want to do is compute the change in log productivity. So let's go first down here to this part B. So the change in log productivity is going to be the new minus the old log productivity. So the new is 2.6 minus the old 2.4, which gives us 0.2, which is the change in log productivity. I had to move my screen over here. So the change in log productivity. Now, if we want to also compute the percent change in log productivity, we would also do that at this time, and this would be the percent change in log productivity, which is going to be the new minus old, so 2.6 minus 2.4 divided by the old, which is 2.4. And we're going to divide that, and we're going to get 0.80. We'll divide that out. We're going to set our calculators to 3 decimal points, because if we don't, we're going to get different answers. So we'll say that we have an increase in log productivity by about 8.3%. Now let's do the new labor productivity the same way, and I'm going to pause the video and I want you to go ahead and do it yourself and then come back on and check your work against mine. So you can see that I've now calculated the new labor productivity as 0.844, because we take 260 and we're going to divide that by 3 times 100 plus 8. And be careful with your calculators that you put in parentheses as necessary so you get the right answer. And then we calculate the percent change in labor, we calculate the change in labor productivity by taking new minus old. So we've got new minus old, 0.844 minus 0.800. That's going to be this 0.044. But then to compute the percent change in labor productivity, we've got to do the new minus old over the old. So that's what we have here. This is the change on the numerator here. And then we divide it by the old for an increase of 0.055%. So a couple of areas where I often see problems, just to kind of point it out, is right here is number 1. If you do not put parentheses in your calculator correctly, you will not get the right answer. If you just take 260 and divide it by 3 times 100 plus 8, you will get 8,674, because you've got an order of operations problem. So make sure you put the parentheses in correctly. So that's one. And then the second thing I see problems with is here. If you do not have your calculator set to 3 decimal places, you will get a different answer than me every time. So you gotta set to 3 decimal places. You have to set the calculator to 3 decimal places. You can't, you cannot just round it to 3. You have to set it to 3, otherwise the internal calculations will be off. So those are the two things that I would be careful of. Alrighty, I hope you found this helpful, and from here you should take a look at a couple of homework problems. So here I have written out the same thing, just a little clearer, a little bit more space, and we interpret this as an increase in log productivity here by 8.3% and an increase in labor productivity by about 5.5%. Now, if you want to hang on just a little bit longer, I'll go through and work this problem, homework problem 1.2, down here for you, which is actually a problem from the textbook that I just put on here, just as a practice problem for class. So we'll go ahead and read this. Carbondale Casting produces cast bronze valves on a 10-person assembly line per day, and he makes 160 valves in an 8-hour shift. So we want to calculate the labor productivity of the line. So when we read this problem, one of the things we want to notice is that they're asking us to compute the labor productivity for the line. So that's important, because that means that we need to have labor hours in the denominator. So we want output divided by labor hours, which is what you see I have written over here. So our output is 160 valves or units, and our input's going to be 8 hours of labor and 10 people. So we essentially have a total of 80 labor hours right here. So we go ahead then and we calculate it. We've got our 160 units that are our output, and we're going to divide that by 80. So we're going to have 2 valves per hour. That's our labor productivity, is 2 per hour. Now, he wants to, or he's able to change the layout to produce 180 units per 8-hour shift. So now he wants to know what the new labor productivity is going to be. So we're going to do the same thing. We're going to put our output, but now it's going to be 180. And our input is still going to be 80 hours, because we still have 8-hour work shift, and we have to assume that we still have 10 people because he didn't say anything about that. So we've got 80 here. So now we're going to do 180 divided by 80, which will give us 2.25 valves per labor hour. So we can then calculate the percent change in productivity by taking new minus old divided by old. So we take new minus old divided by old, and we set it up. We compute the change. We can divide it by 2, because that's the old, and we have an increase then in productivity by 12.5%. So now what I'd like you to do is take a few minutes to work these problems here on page 21, problems 1.3 and 1.5. And this problem that we just worked, as well as these, will be clicker questions for class on Tuesday. So it's probably a good idea to take a look at them and make sure you understand them. So I hope this was helpful in clarifying any questions you might have on how to do the homework problems. And we'll see you soon.